Thanks for coming to the Meetup talk. So this talk, I'm going to do a presentation at OpenStack Summit. And that's the title of my talk there. Just to introduce myself, I'm Praveen Yagadula. I'm a member of technical staff at AviNetworks.com. AviNetworks is a small startup. So today my goal is basically it's a forcing function for me to get my talk ready. So you are my guinea pigs for my dry run, whatever, for the OpenStack Summit talk. But since it's still in pretty rough form, so let's make it more interactive. So feel free to stop me at any point, ask any questions you guys have, give me feedback at that point, or give me. I would greatly appreciate if you can give me some feedback at the end. Mainly on two things, like what you like or what you didn't like, or what you want to know more about, anything that details that you wanted to more like learn about, and so on. Okay, so I'll start now. The talk I'm going to do is about like OpenStack APIs and our experience in using and building our distributed application, a scalable service that we are building on top of OpenStack. And this is mostly trying to figure out, mostly trying to tell you a little bit about like what we found good about OpenStack APIs as it's building this, and what are the some of the obstacles we have to cross over. So to give the context, as I was saying, our goal was to build an enterprise-grade scalable service. So this is not a regular application where you have web servers and so on. So what we are trying to build is more like a high-performance network service. And the kind of requirements that we have is that it should be elastic in the sense that we should be able to provide resources as there is more workload to handle, and scale out, scale in. High availability is one of the big requirements. And we wanted to tenant isolation so that we can do self-provisioning so that users can come to whatever our application portal and can create new network service instances. And obviously, we wanted high performance. So one of the goals that we had was to build it on top of OpenStack instead of in or alongside OpenStack. As I explained a little bit more about our application, you'll understand what I mean. But the main thing is that if you think about OpenStack, you have at the core like Nova, Neutron, providing the compute and network virtualization, right? So as you build more services in OpenStack, you want to build it on top of OpenStack so that you leverage these APIs, just purely APIs, rather than putting something inside and talking to the message queues that are going between Nova and Neutron, or writing something in neutron.conf. That's basically makes it live when you are administering OpenStack, because you want to build things in layers. So as you build your service and app, you can use just the core APIs and just the APIs that the Nova and Neutron provide and build your service. That's the perfect like layering that you can get. So this is mostly about that. Like I'll try to walk you through like what our application does, what we are trying to build, and then talk about like what are the hard things that we have seen as we try to build our, like this is a network service that we are trying to build, and it's basically very high performance one, and it requires our APIs to be really solid, like Nova Neutron APIs to be really solid. Only then you can really really build this kind of an application. And when I say on OpenStack, I described it, but why you don't want to do it inside OpenStack is like you want to make this makes it managing the service itself very easy, because if it is inside Neutron, you'll be tied to like Neutron or Nova cycles and so on. Like if you build the application on top, then you basically are separating yourselves from those core APIs. And also, like if you do it alongside OpenStack, which is basically saying that if you do it outside OpenStack and provide the service, the problem is that you have to another service to manage. So let me jump into the application so that I can tell you a little bit more about what the application that we were trying to build. Some of you may have seen some of these slides before. So the application that we are trying to build is an enterprise-grade load balancer as a service. So you have let me tell you a little bit about the load balancers. If not all of you may be familiar with the load balancers, but I'll just briefly go through what load balancers are and what we are trying to achieve here. So the goal for any application development is that you want high availability. So if you have just one web server and you have users coming to your application, and if something goes wrong, that's not good. So we typically have multiple web servers, but then you need to spread your traffic among those. So you put what's typically a load balancer in front of it and distribute the traffic across those application instances. Now, you don't want to have just one of it. Basically, you want for high availability, maybe multiple of them. So in this case, load balancer, as if one of the servers goes down, it keeps monitoring these backend servers and stops sending any requests to it. This is a very basic load balancer concept. And you have something like multiple tiers in your application. So people typically put load balancers in front of each of these tiers. And you have lots of traffic which is coming from up to going to your first level web servers, and then you have something like east-west traffic. So what we are trying to build here is these basically load balancers as a software. Now, at this level, it looks like these load balancers are not doing that much work. They're just getting some packets and distributing them. So you would think that maybe just like it just needs to provide enough network. It should just get enough network capacity so that it can do this distribution. But one thing that has happened is that there is a lot more that is expected out of the load balancer. So these are like several examples just to say, like an enterprise-grade load balancers today have like tons of features. It's essentially almost like a scripting engine that you're putting in front of your applications, where you can even push like whatever functionality that you want to push out of your application logic into this box. So that's why I'm calling this as like some kind of a network function or network service that we are implementing in those boxes. So you have beyond basic load balancing, there are things like session persistence, where you want to preserve the requests coming from a single user or single browser session to one single backend. And as time goes on, you always want to send those requests back to that same server. This requires that the load balancers to be stateful. So they need to keep some state around them. They need to basically do computations. The second kind of things that you have are the intelligent load balancing. This is basically, say, I have one example to say, you have users coming in while they're browsing like all the items that you have in your catalog. You may want to send them to some kind of low quality regular servers. But once they hit the cart or checkout, where they're putting their credit card or whatever they're into their account or something, then you want to probably put them onto your premium VM so that the response times and everything is good. That's a very toy example, but that gives a flavor of the kind of things that starts to add into this load balancer, whatever the load balancer task is. The even harder thing is the SSL termination. This is one of the things that people want to put in, and the SSL termination is basically moving all the owners of SSL handshakes and user authentication to the load balancers. Now, SSL is pretty resource intensive. So like if you're particularly the handshake phase. So, and the other reason why people want to move is that you also can apply enterprise security policies easily in single central place.
Load balancer ahead decision making and where the application or web server is going to be placed.
So
if it doesn't, you still may have a bottleneck. If two web servers are using the same host, it doesn't make any sense.
Okay, so let me repeat the question for people on the Hangout. So the question is, does load balancers care about where the backend applications are placed, or does it have any influence in where they get placed? Right. So there are different deployment models. In some cases, the application deployment might be done through some other way, and just the load balancer gets invoked saying that I want load balance across these applications. So in some cases, it may have control over it. Some cases, it may not have control over it. So the baseline is assuming that it doesn't have control over where the application servers themselves are placed, or it could just assume that they are placed somewhere. And one of the things that the load balancer can do is try to place its work closer to these application VMs. So I'll tell what I mean by that in a little bit. So as I talk about the architecture, I will come back to that point.
some of this intelligence could be on the back end.
Yes, that's some of the intelligence will be on the back end. The reason why people move a lot of this common logic into these load balancers is basically it's making it easy for application developers to just focus on the application logic rather than these common elements. For example, user authentication. They don't need to worry about like what exact SSL ciphers to allow and not allow, and what like whenever SSL version 3 went down and then nobody wants to use it, you need to now turn it off and start to support only. All those decisions can be moved into somebody who knows that well. So just give them access to the load balancer, they will manage it. And they will give you that, okay, this is the user, we authenticated now, just do something with respect to that user. So you can basically, it's the chain of trust, right? Like you are giving that trust to somebody else to do that some computation. So that's the reason. Okay, so let me tell you a little bit about what we are, the architecture of our application. So this is kind of a legacy way that load balancers work. Like you have load balancers on the side. Typically, this is the model that I was calling like the alongside OpenStack. Like you have the main OpenStack, and then you have this load balancer, like the traditional box-based load balancer, sitting on the side. So there you have to do the management of them separately, and if you are not basically leveraging any of the OpenStack APIs to do the to manage those. And in contrast, what the service VM architecture is basically, it's a distributed load balancer with centralized control. It's like an SDN architecture. So you have controllers and all these load balancer instances. These are running as virtual machines in OpenStack, on top of OpenStack. Essentially, you're just using the Nova APIs to create these VMs and plug in them into the right neutron networks and get the traffic and send the traffic, process the network packets as they come in, and all those things.
Like, do you have the plugin built?
Sorry?
Do you have to build a plugin for your network?
No, there's no plugin needed, right? Like because that's the beauty of this. We are saying that build it on top of OpenStack, just using Neutron APIs, Nova APIs. I don't care what plugin you are implementing underneath, because all I'm saying is, let me talk a little bit more, and then it will become clear. So at a high level, this is the architecture that you have. As I was mentioning, it's a software-defined networking kind of SD service kind of an architecture where you have a controller at the middle. That's where all the configuration is maintained about like what load balancers that you want to instantiate and everything. And the main thing is you have at the bottom these service engines. Those are the tiny VMs or very efficient VMs that are the ones that are really handling the traffic. This is like the software-defined networking where you have all these switches that are simple, that are doing packet forwarding, and you have a brain, the SDN controller that's the one managing things, that's saying what to do for the packets and so on. It's similar architecture. So all the configuration, everything is done in that single point of controllers. Basically, you have multiple of those for high availability, but it's logically centralized. And then you have all these service engines. Those are the data plane engines that are doing the task. And you have, like in this picture, this is showing like what we have finally achieved. But it's basically the controller is talking to Nova, Keystone, Neutron to basically put these service engine VMs in the right place so that it can do the load balance. So let me walk through a little bit of just how like it lays out in an OpenStack deployment. So you have OpenStack controllers. So one of the things that you do is like you have a RE controller, like your controller, it could be running as a VM. So it's again, we wanted our solution to be entirely on top of OpenStack. So it's a VM. You create a project, you create a RE controller VM on top of it, and then you create a network in it. And that's what it's connected to. And you need to configure the controller so that it can talk to Nova Neutron, like public URLs, right? It's like, so for that to happen, you need to basically somehow get RE controller, be able to go out, talk to these services. So, and once you have those, now let's suppose you have two servers to which you want to load balance. That's where you want to, you're getting some traffic on that network, on the server network itself, and you want to load balance the traffic to these two backend servers. So what RE controller does is it's basically controller. It talks to Nova, creates these service engines, and uses the Nova and Neutron APIs to plug them into the right networks. In this case, we have one leg in the control management network so that RE controller can talk to those. And then you have one leg in the server network so that it can send the traffic to the backend servers or receive the traffic. You can have another case where your front-end traffic, the front side from the client traffic may be coming in from another network. So you can plug that also into those service engines so that service engines can receive the traffic. In this example, I'm going to keep it simple and say the incoming traffic is also coming on the Glue network, and it's then going to load balance it to these two servers. So in this case, as you receive the traffic, the load balancer will get and send the traffic out, load balance to the backend servers. Yes, Sal.
The communication between the API, UI, and the API controller can it use heap templates?
To create the load balancers? Yes.
I mean, just the communication. The API controller can it use heap orchestration?
So we have done orchestration so that you can use, basically there is from all the way from load balancer APIs, you can create these load balancer instances, or you can call the AVI APIs directly, RESTful APIs to create those load balancer instances. The heat template part, I would recommend, like if you're doing via heat, there is basically heat already has resources for LBAS version 1 and version 2, so you can create the instances through them. But that requires that you need to have AVI driver in Neutron's LBAS. So that's one addition, that optional addition that you need to have. Yeah.
Question.
Yes.
So you were mentioning about the APIs to create the load balancers. So is it like integrated with the Neutron LBAS API?
So we have both versions. So in the sense that to be able to work with, so let me go back to this previous picture. Yeah. So here I was saying that we have LBAS, and LBAS load balancer configuration comes to the AVI controller too. This can happen only if you put AVI driver in the Neutron core, in the Neutron LBAS core. So
it's called as a part of the service plugin.
It's called as part of a service plugin. So right now today, the LBAS is tightly integrated into the Neutron. At some point when it goes off, then in the Keystone catalog, you will have an LBAS service endpoint. At that point, somebody can register just AVI controller as the service endpoint for LBAS, then it will come directly to it.
It's strictly not application running on top of OpenStack. Right?
So that's where I was saying I was not going there, basically, because that's kind of still, I would say, optional in the sense that our goal is not necessarily for admins to install this. Like as a user, if I have OpenStack account, like we have a bunch of cases where users have like three tenant accounts, and they want to use their load balancer with like full featured load balancer. Today, they are dependent on using whatever load balancer that the provider provides. There is no way for you to, like, the only way is basically you have to build something on top. And this is basically what you can do. So this deployment, basically the way that we build it allows like lots of flexible deployment models. So that's the main beauty of it.
The other question is in the next slide.
Okay.
Maybe you may cover this later. So you have two load balancers, right? Service engine 1 and 2. Is that HA?
Yes.
And if not, how do you achieve HA? How do you achieve HA of load balancer?
Yeah, so this is for HA. Actually, that's a very good point. That's what I'm going to as the next point. So it's a good segue. So as you see here, AVI controllers basically can get elasticity by creating a lot more of these and reducing them as needed. So as you create more load balancers, we can create more of these service engines and start to deploy these different load balancers on different service engines. And you have the second aspect is high availability. So you can, in this case, I'm showing two of them, and the traffic is coming mainly to the service engine 1, and it is sending the load balancer. And the idea there is that if you have one service engine goes away, then we should be able to quickly detect that, start to attract the same IP address traffic onto the other SE and load balance it.
If you are running something like keep alive.
Yes, so there will be keep alives running between those service engines that are like, you can have active-active or active-passive. So in all cases, we have basically some heartbeats going on between the service engines to figure out that when things are down. So one thing I wanted to point out here is that notice that like we basically want to be able to know quickly when some service engine goes down. Like in a OpenStack case, like you have no one Neutron and so on. And this is one of the requirements that we have is we want to be able to know when something bad happens to our instances or to the connectivity and so on. And the other thing is we we be able to move the traffic for the same IP address from one VM to another VM very quickly. That's also another requirement that we have.
So could you quantify the time frame or just milliseconds or just the heart? I mean,
so the answer for that one is as fast as possible for basically moving this traffic in this kind of bad case.
and
But
the reason I ask is for SLAs.
yes, exactly. So our goal has been to do it in few seconds. Most of the requirements that we have seen across customers is they're happy if it is like few seconds, 2 to 5 seconds. Now you can do it faster, like as I was mentioning, like you have heartbeats going on between these, and so based on like how quickly you do it, you don't want to have too many false negatives either, right? So that's the most concern that we had, and in different OpenStacks, like there are cases where the network fluctuates so much because you don't have like too much tight control on this. There are cases where people, like I'll talk about like deployment models because these are all VMs. There are cases where people can put these VMs on like on a subset of machines where they say that nothing else will run, so that you get like better guarantees there. And then we can give even faster. Like you can then turn the knobs down to say that even 2 missed pings, heartbeats, then consider it as a bad case and move it. So those kind of like you can do more aggressive switchovers. Like you can do almost like, I mean, these heartbeats today, yeah, up and down based on how your environment is and what guarantees that you want.
It's based on missed pins.
It's based on missed pings, essentially. Yeah. So as I was saying, like one of the things is that be able to move the traffic, not just during the, like when something goes down. The other thing is, as I was saying, like elasticity, as more load balancers are created, we want to be able to move the IP addresses from one service engine to another service engine. Let's suppose there are 3 applications and they all got assigned to service engine 1, and one application start to use a lot of traffic, then you want to move that application from service engine 1 to service engine 2. And you don't want to have disruption of traffic at that point. It should be like a non-disruptive migration. It should be a like nice migration. And again, I'm bringing up all this so that I can later say what worked when we were doing it with OpenStack APIs and what we had to do, how we had to get around to achieve some of these things. Okay. So the other thing that's possible with this model is that you can do strong isolation because you can create different service engines for like your different tenants or different applications. So you can say like, this is very strongly isolated. So for example, like this is a very useful point for some of the customers where they had enabled people to use something like iRules, if you guys are familiar with it. Like it's basically you can do a lot more processing. Like as it's showed, like you can put a lot of rules in these load balancers to do processing. Now, this isolation allows, because these are all isolated, those customers could allow users to do whatever they want to, because only their service engines are going to be affected. So that's one of the very good reason that people like this idea that everything is isolated, so different tenants, they can play whatever they want to within their tenancy. And that's the point of virtualization, right? That's the point of all Nova Neutron virtualization. Yes?
How we control it per tenant, per project, or is it?
No. So it's not per tenant or per project. You can think of it as a common thing. Yeah. Okay. Okay, so as I was saying, like this service VM architecture allows like flexible deployment models. Some of the questions came up on how it will be useful. So here I've just put some picture of like 2 tenants and 2 service engines and the AI controller. And you can have different kind of deployment models because it's all based on virtual machines, right? It's all based on virtual machines plugged into these Neutron networks. So you can actually move them, put them anywhere you want, and do all kinds of tricks. And based on what the needs are, what's the requirements are, you can do all these cool things. So one of the things is that service engines in tenant context, where you basically create them in the tenant context, and they're still connected to the other control in the management network in a separate context. Or you can have all the service engines be created in a common service tenant context so that they can charge based on how many load balancers created rather than how many VMs that they're using. So it's basically different chargeback model and different ways that people want to manage. And you can also even merge those two if you don't like, if people don't care about like having isolation between these tenants, then they can say, okay, you can just use some common set of service engines for your traffic. So all those models are possible once you have like, because we are just building on top of OpenStack and not using anything inside and just using the APIs on the top, you can do all these kind of things. So just to summarize the application again and to say like these different aspects and what kind of requirements that we had. So what we are building is a high performance virtualized network service as a service. And you have like these kind of 4 high level criteria that we wanted to have elasticity so that your applications, these applications can scale. So for that, you need to be able to create, delete VMs, attach them to the right networks, move these to the right networks with the right IP addresses and so on. And the second aspect is high availability. As I mentioned, that we want to be able to detect VM or network disruptions as quickly as possible. Sometimes, like ideally, it would be better if we have some other way to get them, or we basically have to depend on heartbeats. And be able to switch over the network traffic really fast. That's another thing. And then multi-tenancy aspects that I mentioned, that's already like, because of the OpenStack APIs that we already have it, but just wanted to mention that that's one. And then finally, the high performance by efficiency, that if you have a large number of virtual services or these load balancers that one puts in, you want to be able to still support a large number of them with minimal number of resource footprint. So to that, we need to be able to do something like multiple IPs on a single interface, and we want to be able to handle like get a lot of packets, high packets per second into the VM and so on. Okay, so I will stop here just for a second because I'm going to segue into talking about the OpenStack APIs. So any questions at this point on this application?
So does it also show the whole analytics which you get with API? Because you have a lot of information which you provide to your controller dashboard, right?
Right.
So you get the same kind of view and rich features when you go to that model?
Yeah, it doesn't matter because again, so think of our API controllers are running as simple VMs, right? Now, if the analytics, etc., can be consumed from the API controller UI, so you can do just from the UI. Now, if you are coming from the LPAS APIs, then obviously there is nothing that you can do at that point to get the information. But we have done some extensions on the horizon. We open source the stuff so that there are separate tabs that gets added in your load balancer panel. I'm not focusing on that today, but we can walk you through like how it looks. So it just basically becomes separate panels in the load balancer to show like all these analytics stuff. Yeah, in the horizon itself. So it's basically because we are integrated into the Keystone, from the horizon, it basically already you have all the Keystone tokens, etc. in the horizon. So it just uses that same tokens, etc. to talk to RV and bring the analytics in the right tenant context with the right application and so on. Yeah.
Quick question, again, the previous slide. So you, basically where you were showing the HA. So you said you can also do active HA. Right? How do you do that? Like you put one more load balancer in?
It's exactly something like that. So it's a hierarchical load balancers in some sense, but the one level is folded down in the sense that the traffic comes to one service engine. Instead of processing it right away, it basically punts some of it, a portion of it to the secondary. The reason, again, this is also another OpenStack API limitation, which I wasn't going into this case, is basically we wanted to have like kind of ECMP support so that you can say these two load balancers are active. So from the router itself, if you can get that.
You have to advertise the same IP to the outside.
Yes, but today in OpenStack there is nothing. I mean, unless I guess as more L3 services are coming in at some point, there will be APIs to do that. But at this point, with the core APIs, there is nothing like that. So. Okay, so let's move on.
So I wanted to ask about high performance. Since you're using the hypervisor, how are you able to guarantee high performance?
Yeah, so there are multiple levels of answers to that. One, high performance. When I say high performance, is basically we want to be able to get at least the packets at the rate a leak is received, right? So assume that we are not doing any network. You're right, like because of the hypervisor, there is some degradation in the packets per second that you can receive. Is that the question that you're asking, or?
Yeah, well, you're limited by what the performance of the hypervisor.
Yes, exactly. So that's the point I was trying to say, that for building it from the application point of view, yes, I would like to use your virtualized environment, but will I get a high number of packets or not? That's basically is the requirement that I'm putting here. We'll talk about some of it down the line, like how well it performs, or how well, like some of the things that we have seen while running it in the OpenStack reference implementation.
Okay. One last thing. So you mentioned that you had said something about Neutron plugins. Are you meaning to say that you can support any configuration of Neutron, or is there a particular configuration that you guys need?
So ideally, we support any configuration of Neutron as long as the Neutron APIs basically work, in the sense that the core APIs work, that we be able to plug in a VM into a specific network, get the traffic for a IP address, that specified IP address, and so on. But I'll go through some of the issues that we have run into. I was not planning to go very deep into one of those aspects, which is basically we needed allowed address space extension to work. Otherwise, we were not able to attract the traffic. I'll just refer to that in one of the slides. But yeah. Otherwise, we are agnostic to how exactly which plugin it is underneath, as long as it supports the core basic Neutron APIs and either allowed address pairs or port security.
Okay, so basically Kilo and above is what you need. I assume that you need LBAS v2 as well.
Sorry?
I assume that you require LBAS v2 as well.
No, as I was saying, the LBAS APIs are separate. So there are two different aspects, right? Like one is somebody can come to RV and consume the load balancing as a service, right? And then the second one is basically going via LBAS APIs. So these two are two different aspects, and the sense that the LBAS APIs get converted into RV APIs if you basically, that's what our driver does. Basically, some user wants to only use LBAS APIs for future proof. I mean, that's one of the valid reasons, right? Like they don't want to use vendor APIs because they will get logged in. So that's why they want to go through the. But again, there are limitations because of the version 1, version 2 have its own limitations. So in those cases, they have a reason to go to directly. So those are the main reasons why, like, whether they use the LBAS APIs or the regular APIs.
Okay, go ahead.
Okay, so let me switch to talking about the OpenStack APIs portion. Now, the OpenStack API, like, there's lots of good points about it, because we said, like, we built this application on top of OpenStack, so we are able to do this, actually, a lot of all those things. So the core ones, like creating the VMs and basically deleting the VMs, allowing like that allowed us to scale out scaling pretty easily. So it's very easy to like create these VMs, put them into the right networks and so on. There are placement options exist. They are though they are a little bit limited, but there is pretty good good enough support for choosing. Like you can choose availability zone, you can choose different hosts within an availability zone, and all those things. Now, one kind of side to it is basically if you have admin privileges, then you can see that. If you don't give us the admin privileges, then we can't see it. So we can't do good job at that point. There is anti-affinity server group facilities in Nova API through which you can say that I want to place this VM in this group. Then any 3 VMs or 2 VMs that you put in the same anti-affinity server group, they get placed on different hosts. As a user, I don't get to see where those hosts are, where they are getting placed, but I can just say that at least they get placed on different physical servers. So that at least gives our, like, as I was talking, high availability is one of the concern, and you don't want the 2 service engines that are doing like active passive or active active for a single application being placed onto the same host, because host is the place where normally you get disconnects. If you have multiple availability zones, you can place them into different availability zones, but we have seen that many times people may not have multiple availability zones or all kinds of things. So, and the next aspect is multi-tenancy. This is one of the things that was like very well thought out from the day one, and it's basically super cool in OpenStack. Like all the isolations and that everything that we want to do is pretty solid. Neutron's basic core CRUD API for creating like all the virtualization at the lowest levels is very cool too. Like you have networks, routers, concept ports, subnets, then You can get information about all of them. You can plug into, you can create ports out of these networks and so on. And it creates basically these multiple tiers with proper isolation and all those things pretty easily. So now, like I said, like all my later slides are mostly talking about the issues with the we have found, but this compacted all the good things about it into one slide. The first thing that we had, as I was mentioning, was that there is no notification support for API from core OpenStack services. So if I created a Nova VM, I won't know when it goes down or when something happens to it. There are ways in the sense that the Nova itself doesn't provide any way a notification service. Nothing like that is present in today's OpenStack. So you have similar with Neutron, like there's no way to quickly detect if something happens to the port. And Keystone is no way to determine if some tenant is disappeared. Basically, essentially, these are all pointing to like you have these services, and for services, it would be good to have the notification also so that you can subscribe to it and get the notifications to quickly act on it. So once you don't have it, the things that you have to do is periodically check, like doing heartbeats among all these VMs that I have, or in case of Neutron, checking on the ports or checking like if these individual resources that I've created in the Nova Neutron are there or not. Now, oscillometer alerts, and that is a possibility, but we have all the customers that we have come across, most of them, it's not there. I guess there are other projects too on OpenStack, but like we haven't, like this is part of like whatever core projects we haven't seen much notifications. Any questions on this? No?
Yes, so you said you're not using simulator because customers haven't adopted.
So we started to look at that, and then so the customers that we have been working with, none of them have turned it on. Some of them were using Monasca, some of them were using something else, or some of them built their own. Most of them didn't have. So most of them, nobody asked us, like we didn't get back on that. And since we started with few customers that didn't have it, so we started to build all this periodic checking and everything into our stuff. And we said basically that's good enough. Like that gave enough fidelity with respect to detection of different things. Still, the collecting garbage collection in the sense that when some resources go bad, like we try to create a service VM, it doesn't come up. If it doesn't come up at all, we can't even do heartbeats with it, right? Like to figure out what's wrong with it, or to be able to go there and check what. So in that case, the only way is like basically go to Nova and periodically check if all the VMs that we are creating are coming up or not, because we haven't even reached that heartbeat stage to be able to detect that something is wrong. So those kind of garbage collections and so on. And again, we don't want to be, as I was saying, like we don't want to run into too many false negatives either. Like many cases, these VMs take quite a bit of time before they come up, right? So we don't know when, like the Nova itself may say that it's active, but it may take like quite some time before it really comes up, right? There are lots of things that happen even after Nova status shows active. So all those things, like because of that, the periodic check, we implemented the periodic check and we basically stuck to it. So maybe things have gotten better now. Yes, actually just.
No, actually, this is nothing to do with Avi, but it's more like generic. I'm not done any coding on OpenStack, more like a user. So if I say like my VM is running and say I delete the file, the KMU file, right? Doesn't it try to recreate it because if the state is present in the DB, right?
You would expect, but no.
No?
So. Keystone has.
Keystone has no notification, so the tenant deleted.
Uh-huh.
The notification.
Oh, okay, cool. Thanks for pointing out. I'll check on that. Is it V2 or V3? V3. So that's probably a reason why we haven't come across. Mostly we've been using V2. So.
Yeah, you can turn on Kata and then just also messaging with the transport. You know, put a message queue.
But we have to subscribe to the queue.
Of course. How do you get notification otherwise, right?
No, I'm saying like, yeah, that's what I'm saying. So if you're in the running as a VM on top of OpenStack, I don't have access to the message. That's the main point about this. That as running on top of OpenStack, we don't have any way visibility into the notifications. That's the main point about this.
Also, you have no access to that.
No, message queue doesn't have any access for non-OpenStack controllers. Right? If you want to get into the message queue, the only way that you can do is by creating a service that's running in OpenStack and be able to connect to it. And that means basically administrators have to administer one message. So we are trying to do that. That's the main. Any other things? Okay, so this is one of the other things that I think it happened because of organically grown OpenStack, in the sense that Nova initially had networking as part of it, and slowly Neutron got there, and also some engineering constraints because of which people did it. Which is that there is no proper separation of concerns in the Nova network and the Neutron port, Nova interface and the Neutron port. So on the left-hand side, I have the physical world where you have a physical server and switches, and on the right-hand side, we have the OpenStack equivalents like virtualized Nova VM and Neutron networks on the right-hand side, right? So those are like one-to-one concepts of virtualized switches, your Nova network. Now, in the switches, you have ports, and in the physical world, and you have physical servers have typically your NICs that and you basically plug in the wire between them. Unfortunately, on this OpenStack, because of the way that initially we built up.
Sorry to interrupt. That's
This is not what making sense.
it's making a lot of sound. Let me try this one.
Maybe.
Or maybe I think it's just getting interference. You want to just try this one for a while?
Okay.
Just try to turn that off. One less hand. Let's see. Yeah, I think it went a little bit better.
Okay. Yeah. Unfortunately, on the OpenStack side, we don't have that kind of mapping going from this interfaces that you have in NICs in the physical world to something in the OpenStack APIs, in the resource model I'm talking about. Internally, implementation tries to do something, but I'm mainly talking about from the API perspective. So from the VM perspective, from the Nova VMs, you have IP addresses directly saying that, okay, this VM has this IP addresses. And on the Neutron side, you have ports, but you don't, basically not much you can know about the connectivity or the API ways to really distinguish the similar way that you do in a physical world. So you don't have the interfaces of VMs are not exposed in Nova APIs, and Neutron ports essentially become the Nova interfaces in the implementation. Like the way that's implemented, it's basically they are tied together, they are very tightly, and a lot of problems happen there because of basically we're talking about two different services, Nova and Neutron, and trying to use the same objects like those Neutron ports objects. And then you need to synchronize them well across those two, and so. Now, this also poses some of the issues that that there is no easy way to move an interface, an interface from one network to another. Like as I was showing, when and I was talking about when you have three load balancers implemented by one service engine, and suddenly I decided that I want to move two of them out onto different service engine. I need to be able to move those interfaces, IP addresses on them, and move the interfaces across some networks too. Now, the only way to really achieve that is basically you have to essentially destroy an existing interface and attach another interface. And detaching and attaching network interfaces is heavier than being able to say that just basically switch the VLAN tag on that network, right? So that's one of the things about the Neutron Nova being that, and it came from because it organically grew from initially Nova had the networking, everything being managed inside Nova, and slowly the Neutron moved things out, but there are still vestiges of some of this separation not happening very well in the OpenStack APIs. Any questions on this? Okay, so the other thing that we have run into was the security group APIs, and this is actually the semantics of what, when you call this API, depends on like what the installation is. So you would think that when you're calling API and when there is a semantic that associated with API, and this is one of the common things across like the next few slides, that we have APIs defined, but the semantics of what should happen when you call the API is not really grounded in the sense that we don't have an API document to say, okay, this is the API, and when you call this, this is going to happen, and that's guaranteed. No. So, and that basically says that all these, like let's suppose there's plugins, there's different plugins you put in, and they all allow API call. But once you do the API call, somebody will do something, somebody else will do something. And this happens even in the core ones. Like this is the security group API. So we have like a little bit of inconsistent API semantics for security groups. So in the case of Nova and Neutron, both of them implement the security group APIs. But like an administrator, when deploying the OpenStack, can choose who implements the security group. Just before I go there, I'm assuming that everyone knows what the security groups are. So it's basically, think of as firewall rules that gets applied, and security group is basically a bunch of rules that specify like who's allowed to access the VMs that are part of that security group and who's not allowed, and what these VMs in this group can access and who cannot access. Now, the semantics of it is that if you are in, like if the admin implemented the security groups, and if you are using Nova APIs for the security groups, the semantics is that in the Nova API, just basically all you have are the Nova VMs, right? Like you say, this Nova VM is in this security group. So irrespective of however many interfaces that it has or wherever it is connected to, those policies, whatever you define, are supposed to apply across all those interfaces. Like if you say, don't allow this VM to go to outside 1010 network, don't let it go to web, then that will be applied across all the interfaces, irrespective of whatever interfaces that you have. Whereas on the case of Neutron, the Neutron security groups are tied to per port. So again, the API allows saying that, okay, you take the port and you associate a security group with that port. Now, depending on whether Nova is implementing it or Neutron is implementing security groups, the behavior of the calling these security group APIs can be different. Now, from like an user using somebody's OpenStack, I need to know what they're using. And that information is kind of in the neutron.conf. Obviously, as a user, I don't have visibility. And there is no API to figure this out exactly. Like, the API could be a little bit, like, there is no clear API to get that. You can kind of guess, but it's not definite. Now, also as I was saying, the calling those APIs is basically behavior is inconsistent. So one example is, let's suppose somebody has an OpenStack environment and they're using Neutron to implement the security group. So all the Nova security group calls, basically they get relayed to Neutron in that case. Now, if I use Nova security group API to assign, like say I create a VM and say I want to assign it to my security group. Now, I can later at some point, if I say Nova attach interface, that is create an interface and attach it to Nova, so create one more basically IP address in the Nova attach interface case, or we provide the Neutron port. Then the expectation is that my security group would also apply to this new interface. But unfortunately, what really happens is that it gets the default security. Now, that's the behavior that the the APIs have. I mean, some of it is, you can say that it's reference implementation, but as I was saying, it's about the semantics, right? It's basically the semantics and are not grounded, not like put in stone saying that this should result in this, then basically these kind of inconsistencies can happen. Okay, so let me do time check. How much time do I have?
This means that you can attach an interface to a running view.
You can attach an interface to view. That's what I was saying, like you can detach and attach interfaces, but you can't move interface from one Neutron network to another Neutron network. That I was mentioning in the previous.
So generally you buy security groups on the Nova side or the Neutron side?
Yeah, that's, I don't know. So The general is that actually I'm not totally sure where. Basically, both of them support it. I don't know where where is a good one, where is a good place to apply.
Should be
I mean, if the neutron doesn't, like, if somebody isn't using neutron, then, I mean, global security groups you can always call. Neutron you can only call if the security group extension is enabled in the neutron XDS. So then you can start communicating from security groups.
with Nova, you can't do upper subnet security rules.
Yeah.
With Neutron, you can.
Neutron. Neutron basically gives a lot more fine-grained security groups. Okay. So the rest of it is somewhat like going a little bit of mix of because of the implementation, and it's mostly talking about the semantics of APIs. So as I was saying, semantics of a lot of APIs is left to the interpretation of plugins. And in case of L2 network APIs, I was saying like in physical world, if two machines are plugged into one switch, you can do lots of different things. But in case of OpenStack, like with Neutron plugins, different plugins basically have different kinds of behavior depending on what settings are used and so on. So that also poses a lot of restrictions. Like so in some cases, we have seen that they don't allow multiple fixed IPs on a port, or you can't have same IP on multiple ports and all those things. Now, the other thing that we have run is the no APIs to customize the network connectivity, and this is mostly reference implementation restriction. By default, what happens is when you create a VM, the VM is not allowed to kind of do any kind of source IP spoofing. Now, that's a good measure that you don't want, like as a VM created in a network, you don't want that VM to spoof some other source IP address. But you want to have an API to be able to control that, right? So that the aspect that you don't want to mix many layers into one single layer. So if you're just providing the L2 layer abstraction, then you just stop at the L2 layer abstraction. And then when you want to add some of these restrictions, then you can build it on top of it and say, okay, you have the basic L2 network abstraction, which is to say that if you're plugged into this network, you can send MAC level packets to anyone's connected to that. And that means basically you can send whatever you want to. But if you want to have restriction, then you put another layer on top saying that, okay, this is the restriction APIs that you can use to say that who can talk to what, which is security group APIs. But instead of that, there are these, because the way the APIs are implemented, because they're, again, interpreted differently and, again, organically grown, as I was saying, all those reasons made it that, like, if you create a VM with a specific IP address, it won't be able to send out packets with any other IP address. And you don't have any API to basically turn that off. And essentially, that's kind of built into that. Now, I'm talking about core APIs. So you have some extension APIs that you can use, like the allowed address pairs. That's one of the things that we heavily depend on to be able to, because as I said, it's a network service, right? Like we are saying, we have a network service, and we be able to receive the traffic for all these different multiple IP addresses of these different load balancers onto our VM and be able to send that out. Now, as I said, like different plugins have different issues that we can't assign multiple IP addresses onto the interface, and all the like different restrictions, because of which we had to basically depend on these kind of extensions be available. And port security is one of those extensions where finally that allows you to turn that kind of check off. But I was saying, like, that's not built into the core Neutron API. That means that all these like port security or allowed address pairs may be or may not be available in some of the Neutron plugins.
So in your load balancer, I mean, I have faced the same problem because a router or a L3 is basically forwarded.
Right.
It can send to any source. So are you like bypassing this port security?
Yes. So there are two things, like two checks in some sense you have, right? Like one is how do, like Neutron is the source of truth for like some. Again, it's plugins dependent, right? Some plugins use ARC-based directory. That means that unless you tell the Neutron that this IP address is in this port, no way you can receive packets for that IP address. Now, you want to receive, like let's suppose router functionality, you want to be able to receive all the packets. Then how do you receive it? But there are some plugins which really do ARC broadcast on the VLANs. Like if you're using VLAN-based implementation, they will, or VXLAN-based, they will do real ARC broadcast. In which case you can spoof by saying that, okay, once you receive that ARP for any IP address, you say that, yeah, I have that. But while going out, that gets dropped. So you can use port security to disable that, saying that allow it to go anything. And allowed address pairs also kind of provides that similar functionality. You can put more precise ones, like this is the IP address for which I want to receive traffic, and these are the IP addresses I should be able to send out traffic.
But are you going to change that every time, because your IP can come from anywhere, right?
No, not from, like, once you put it, it's there. Like I'm saying that I want to be able to receive traffic for this IP address 1, 2, 3. I put it into allowed address space, then the expectation is that the router will learn from the ARP table and then will start sending it here. Yeah. Any other things? Okay. Okay, this is the network performance as just I wanted to show that picture to say that we have like very complicated multi-layer thing in reference implementation. Again, this is more reference implementation restriction, and this goes to the person that you were asking, Sean, about what the performance implications are for running inside as a VM. So when we started building this, we have seen that like our product, because as I said, it runs as VMs and it's a virtualized thing. It can run on any virtualization platform. So we basically run on ESX, AWS, or OpenStack, or CloudStack, or Docker, Mesos, blah, blah. Because it's just basically a VM-based code or container-based code. And when we went from ESX to KVM, or basically OpenStack with ML2 ODS, we saw that like the performance has dropped from like lots of traffic that like basically near NIC performance that we can get in ESX to like few hundreds of megabits per second when running in KVM with ML2 OBS VLAN. Now then we started to dig to see like what's there, and basically started to see that there are basically all these layers, and you have like bottlenecks at these different places. This is like about 2 years ago when we were looking at it. Initially, we had the V8 pair bottleneck in older canals, which was the blocking, like which was basically the main bottleneck with respect to packets per second. And that went away after 1204, like the newer canals didn't have it. Then you have the OVS performance issues that caused basically pretty low throughput, low packets per second. Then finally, that one got better in the later versions. And then we have net filter contract issues. That happens because, so in the ML2 OS space, and because of the security groups, like the way that the security groups are implemented, you have multiple layers of these bridges. So you have OVS at the bottom implementing kind of 2 virtual bridges, and then you have a Linux bridge on top. And then you have the net filters acting at the along with the Linux bridge. So then basically made it possible to have like lots of possible bottlenecks in there. But many of the things are getting better. I mean, the recent one that we have is basically right now, the net filter that we have seen is one of the bottlenecks. That's why the port security extension is pretty useful. Again, as implemented in OpenStack today, port security still doesn't take out the Linux bridge on the top or the net filter on the top, but we're hoping that once the APIs come in to be able to remove that, then we'll be basically, once we take that out, we basically get very close to what ESX can get. So that's basically as the benchmark for comparison, because they optimize the hell out of it.
Is it most of your performance problems going to be, I mean, isn't your biggest performance issue going to be the VM that's running the load balancer? Since all traffic's going through it?
No, actually, it's not that bad. So it's the traffic is going through it, but
Is it only control plane? I assume it's data plane as well, right?
Say it again?
I assume you're putting all data plane traffic through your load balancer, or is it not?
Yeah, it is. Basically, all these VMs, those data plane VMs, are all basically receiving the traffic, real traffic. But if you think about it, most of like the if you have one core, the rule of thumb is that it can do every hertz is like the 1 byte of TCP processing that you can do. And we have built our own basically NetBSD-based stack to even get down as much low as possible. Now, as long as hypervisor is not the bottleneck, any packets that we receive, we are basically with respect to just turning it around and sending it out and sending back on its way, we do pretty fast. Now, all the load balancing work, I mean, network service work that I was talking about, like SSL handshakes, which are pretty CPU intensive. So you can do per core maybe like 500 handshakes per second, which is pretty low. But thing is that you can scale it up. You can scale out any CPU thing, you can scale out really up because network is not the bottleneck. Anytime I'm getting the packets, I punt them to basically load balance out to second level of service engines, which are basically then doing the real SSL handshake. So that's the beauty of this elastic scale out and scale in, because then I can create more service engines as I get, say, 5,000. So if I need to handle 5,000 handshakes per second, I basically make it 10,000 and scale that up. And the network bandwidth is not the issue at that point for CPU intensive workloads mostly.
Yeah, I'm not so thinking of network bandwidth. I'm thinking about access to the kernel on the hypervisor that's running your virtual machine.
Why do we need access to the kernel?
The performance of the hypervisor, if it's busy doing other work, it's going to balance the work of your service, with everything else, right?
Yes. You mean to say how we compete against the other VMs running on the same? Yeah. So again, as I was saying, there are our deployment models basically because of the elasticity. Once we figure out that the service engine is not being able to cope up with the kind of traffic that it's getting, we scale it up. So once we create more service engines, they get to other machines.
To another physical machine?
To other physical machines. The second point about it is that because of the deployment model, you can create a separate availability zone with 4 hosts and say, these are the 4 hosts I want to use for your service engines because I don't want to say let your service engines be perturbed by any other compute VMs. So you provide that availability zone in our basically deployment scheme, and then we only use that availability zone to deploy the service engine. So as many as needed on those hosts, and we basically make sure that basically there is no other compute VMs running on those. So all the service engines would get the full whatever CPU that they need at that point. Okay, so as I was mentioning, so many of these issues are fixable, and a lot of them got fixed, and some are. So eventually, we'll reach a case where. It will be all good.
So while you're doing that, I have one last question. So you bring up a lot of good points of limitations in OpenStack. Are you guys planning on participating with Neutron and Nova to fix some of these things?
Yeah, some of them we have been talking like the security groups. We tried, we fought, gave up. So so there's long things of things that went through the security groups, particularly. We submitted a patch, we did the unit test, we did all those, and then people lost interest. In the sense that they put some comments saying that, oh, okay, but if you go through Neutron port API, then that won't work. But it said like you need to. He said that the Nova security group API is supposed to guarantee this, then you need to support that, or you say that you don't support it when Neutron is API, and then provide that explicitly somewhere in the API call, saying that you can't do Nova security group API anymore if you are using Neutron security. But and basically there are only, I guess that's the thing, right? Probably this is cases where there aren't too many complaints about it, so I guess there wasn't too much interest that went into it. So it eventually like died on. I mean, it sent the responses, but then nobody looked at it again and stayed back like that.
So what I would recommend, I wouldn't give up. So since if you are tied with OpenStack and you plan on participating and being an OpenStack service either running with or on top of OpenStack, it takes a while sometimes to get people's attention with real problems. So I wouldn't give up. So these are all valid points. I'm aware of some of these myself. So I would, the community needs these things to be fixed. So I would continue to beat on them. So
okay, thank you.
Please.
I'll make sure to do this.
Okay. All right.
So Praveen, tying back to the initial point that you made, you're on top of it, you build the guy on top. So on a business case, it's a competitive differentiator. That's what you're saying. Like it's stating the obvious, but basically.
Okay.
Gotcha. I'm sorry, I'm just thinking it out loud.
Okay. Okay, so to summarize, saying enterprise, the goal is to build this enterprise-grade scalable service on top of OpenStack with basically elasticity, high availability, high performance, provide self-provisioning, and OpenStack APIs for most of the simple things are pretty great, like the resource allocation, the multi-tenancy aspects, and there is limited. There are some limits with respect to these advanced APIs required for building these high-performance applications, like some missing APIs, or some undefined semantics, and so on. So that's the summary of my talk. Okay. Any questions? Any more questions? Yes.
Tell us a little bit about your API journey. Just a little bit. This takes quite a long time to just build out and just the API development process.
So API development process of our product or API
or just of just your process or just your
just
journey.
learning the OpenStack, with respect to OpenStack APIs.
The up and down journey.
Oh,
Or just
yeah. So the OpenStack API, I mean, we started simple in the sense that we basically, when we initially built the our first round of product, we were just basically using all core APIs. So some of the things that I haven't gotten into here is like the sync. We also wanted to be compatible with the LBAS version 1 and version 2 APIs, which I haven't gone into because here my goal is to more say, if you think of developing an application on top of OpenStack without depending anything in the OpenStack, what are the issues that you run into? But we also went beyond that in the sense that we are also trying to provide LBAS version 1 APIs and LBAS version 2 APIs so that somebody can go through the Neutron LBAS APIs and get to like create a pool, members, virtual service, their load balancer instances essentially. You can go through Neutron LBAS API calls and create them. And we implement them. Basically, we have a driver that runs in Neutron and relays the things to us, and then we create this, right? So, in the first round when we did the first of our one of the things that we ran into is like load balancer, when Neutron load balancer, when you create a Neutron load balancer, it creates a Neutron port and says that that is the port where you will receive the traffic. Now, if you have many of people, like in the enterprise use case, like people have several thousands of load balancers. They basically create tons of these whatever virtual services or virtual servers or whatever different vendors' language. There are different things, but they are load balancer instances. Now, if you have, like, say, 3,000, many of them, like, they create so many. I mean, not everything is in use at all the times, but they have those in the sense that there is some small application. Maybe like it will get 10 requests a day or 20 requests a day, and at the end of the month, maybe receive 100 requests on the last day of the month because of whatever billing cycle or something. But they have this called 3,000, 4,000 applications. Now, if I create a Neutron port for every application, and if I want to attach it to the service instance, now we are talking about creating, there is a limit, right? Like service engine, like these VMs, you can't have more than 24 PCI devices on a VM. That means you can't have like really the network interfaces that you can really attach to these VMs is limited. You can have maybe like about 15. You can take out the storage and so on. You want to leave some. So if I have 3,000, then I need like 150 service engines to create this, and the load is so low, and the 150 VMs is like a lot of physical server. Like then we are talking about like a lot of cost just to get this load balancer implementation. Whereas the traffic, maybe the overall traffic across all of them, maybe 1 Gbps maybe at the most. So those are the things that from that, like when we initially implemented, we were doing one interface and then said, okay, no, this is not very good. So we did the multiple thing, then we ran into these issues that, okay, you can't really put multiple IP addresses on a single interface because it doesn't work with some plugins. Then, or even if it works, there are other issues like load balancer, Neutron LBAS creates this port and it puts the fixed IP address there. No, I'm not using that port, but I'm putting one more IP address on my port that I have connected to my service engine. But unfortunately, reference implementation doesn't allow it. Most plugins don't allow putting the same fixed IP on two interfaces. Like you can't do that. So I have to take away the IP address from the neutron load balancer created port and put it on my service engine, in which case the load balancer goes all haywire because it thinks that it's supposed to own that IP address on the port that it created. Suddenly it disappears from the horizon, it doesn't show up when you do the CL. It's all messy there. So those are all things that we had to go over. So we said, okay, we'll use the allowed address space to get around it. So we found about allowed address space. We said, okay, we'll use that so that you leave the load balancer ports as it is, but still be able to attract the traffic for this. And then we can also create multiple IP addresses in the allowed address space. And then we run into these performance issues that we talked about. We were coming from, like, when we initially did, we were doing it mostly on ESX and then did on OpenStack, and there you can get like 600 PPS, and here you're talking about tens of thousands of PPS. This is not good. So then we went through all the exercise of figuring out what was wrong. Now, again, so we can do all these things, but when we go into customer deployment, they may have whatever version that they have. So we have to basically tell them that, okay, you want to upgrade it. But many of them are like pretty smart in the sense that people who are actually adopting at that point OpenStack, they're all very good too. They're all on the cutting edge. And they were doing like, yeah, we already upgraded to 2.02 because that's the one that does very well. And so all those things. Like, but now we started to see that the people are coming in who really are not on the cutting edge, but still using OpenStack. But their things have evolved enough now that we can go and do it without running into too many issues. I mean, we have found workarounds for most of the things, and we can deploy pretty stable.
So most of what you've developed has been through the customer. It's what the customers have been asking for.
In respect to what?
Just the biggest issue that you addressed was it came from a proof of concept. It came from directly from the customer. Basically.
With respect to scalability, you are talking about, yes. Yeah. That was, I mean, that was there even before we started on OpenStack in the sense that I was saying, like, and when we did the architecture, it was to work on any virtualized infrastructure. And we started with ESX just before starting on OpenStack. So, and then after like about 6 months of doing it on that, then we started on OpenStack. So along the way, we knew like what different customers wanted. With respect to sizing, especially to talk about the scale at which we want to work.
Regarding the OpenStack release that you worked on, do you try to always be the latest one, or you're staying behind and looking at stability?
So as I was saying, like we try to use as much as code APIs as possible. So when we tested with like last one was Kilo that we tested with, and we will test and it gets released, we will do it. But from going from Juno to Kilo, all the testing that we had to do was just run our regression test against it. That's it. And we didn't have to fix even a single line of code because it's all built on top of OpenStack. From this product perspective, from the perspective of the LBAS driver, as one of the things I was mentioning, like, because there is a AVI driver that sits in the Neutron LBAS to relay the calls. That one we had to modify because things changed when we went to Kilo. The Neutron LBAS got moved out of Neutron. So we had to repackage our driver a little bit differently. But as I said, like the controller and everything, the AVI controller and the AVI service engines, those are all, it's purely running as VMs on top of any infrastructure, right? So basically, there was nothing needed to change because then there were all the Keystone API calls or the Nova, Neutron API calls to look up the networks, plug into them. They haven't changed much since almost like Havan. So they'll be there, like the same. So we didn't have to do too much. So every release, all we need to do is basically just make sure that we can deploy. As there are new things that get added, like one thing that we have found, I mean, once DVR was in, like DVR, with DVR, you don't have the allowed address pairs functionality working, at least in the Kilo. I don't know about the Liberty, I'll have to check with them. But if you enable DVR, then the functionality, some of the functionality will get broken, and you have to figure out some other ways to get out at that point. But those are the things. I mean, as mostly the core-wise, Everything stays same, all the APIs, so we don't have to worry about, we didn't have to worry about it. As long as I was saying, the only workaround we have to depend on was this allowable spares. That's the only one that gives us because like something new comes in and that breaks the allowable spare. Because that's not core, it doesn't get tested the same way.
What kind of customers do you have? Can you talk about that at all?
Yeah, so the kind of customers that we have are, the one big one we have is public. So we have in the two major segments where we have the big customers. One is the one public cloud customer that we have. And they basically are deploying it in the, I mean, I guess the second kind of customer that we have is an enterprise customer. It's a cable company customer. And there, the scale for the enterprise customer is about, I think, 200 to 400 servers per site, and they have currently 2 sites and going to 1 more site. So that's the cable customer one. And the cloud service provider is big, but still they're still building up, like on site. Probably rolled out to 5 or 6 sites by the end of this month.
Thanks.
Okay, thank you guys. And if you have any comments or especially if you have any comments, please feel free to email me or greatly appreciate anything that you guys have. Let me see.